Chapter 3E looks at how to interpret a scatterplot. First thing you want to do is look for a clear pattern to decide if the two variables being the explanatory variable, which is on the x-axis, and the response variable, which is on the y-axis, to see if they're associated. And when we talk about a clear pattern, it could either be linear or curved, linear being a straight line. So looking at these two examples, this one here, there is no obvious pattern. So we say there is no association between the explanatory and response variables. Whereas this one, there is a clear pattern. So there is an association between these two variables. If there is an association, we can describe it by looking for the direction and outliers, the form and strength. Let's look how we would define these ones. So the direction, you're either going to have a positive or a negative association, which is like the gradient of the scatter plot. Outliers, you're just stating any obvious outliers. Form is described whether it is linear, which is a straight line, or is it curved? If it is linear, we say it is linearly associated. And if it's curved, it's a non-linear association. Finally, strength. It only talks about the straight line. We talk about how well does it fit into a straight line. So let's describe this scatter plot using these four descriptors. We've got the direction. Well, as we go along the scatter plot, the points are getting higher and higher. So this is a positive association. As for the outliers, we have two outliers, these 2 points here, because they don't fit into the general shape of the scatter plot form. To me, that looks like it's a fairly straight line, so it is linearly associated. Now the strength. This is a bit ambiguous because the strength is how well does it fit into the straight line. But we haven't yet defined, how do we define how well something fits into a straight line? So to do that, we're going to look at measuring strength, which uses the correlation coefficient. Now I'm going to underline this because this is an important term that is going to pop out throughout the rest of statistics. Now the correlation coefficient you will always see it denoted by the letter R. So the letter R is always the correlation coefficient. And it ranges between -1 and 1. Now we can use this table and these graphs to get a rough estimate of what this correlation coefficient looks like. If we look at this first one, this is R equals -1. This is a perfectly negative association. So the straight line is perfect. So R is as negative as it could possibly be. We move over to this next one. R is -0.7. So we're not quite at 1, but it's still a fairly strong or moderate negative association. As we get closer to 0, we can see the values are getting more and more spread out. And then at R equals 0, this is no association whatsoever. So there's no clear pattern going on here. As we move into positive, R gets a little bit larger. We can start seeing a pattern, and now it is a positive association. We get closer again to 1, and our strength, we can see that the values are fitting more and more into a linear fashion. And finally, at R is +1, we've got a perfect positive linear association. So it's perfectly linear. Now, if we wanted to name these, we can use this chart here. So if R is between 0.75 and 0.99, we've got a strong positive association. So this one down here would be defined as strong positive. Moderate is between 0.5 and 0.74. So we would name this one as moderate positive. R is 0, so there's no association here. If you have between -0.24 and +0.24, you have no association. Weak negative, between -0.25 and 0.49. So this one would be classified as weak negative. Between -0.5 and -0.74 is a moderate negative association. So we'll classify this as moderate negative as well. Now it's important to note, you need to be careful. If you're using the correlation coefficient to determine strength, you're assuming that the form is linear and there's no outliers. So what this means is if you have a curved association, you cannot use the correlation coefficient to determine strength. It's only for linear associations. And if there are outliers, the correlation coefficient will be greatly affected by these outliers. So if you're using the correlation coefficient to determine strength, you are assuming that it is linear with no outliers. So finally, let's look at a quick example. Let's see if we can describe and interpret the shape of this scatter plot. First, let's consider its direction. Well, as we go along the scatter plot, the values are getting higher and higher. So we definitely have a positive association. Outliers, there are no outliers. As for the form, this definitely does look linear. There doesn't look to be any curves here. So it is linear. And the strength, well, if we think back to those example diagrams, it could be interpreted as strong or moderate, but we're going to go with strong here. So we're looking at our options. We've got weak positive linear. Well, it's definitely not weak, so it can't be that one. Weak negative linear, definitely not negative or weak. Moderate positive nonlinear, it's definitely linear, so not that one. Not D either, because it's definitely linear. And E is strong, positive, and linear, which is what we've got here. We've got a strong positive association that is linear. So the answer would be E for this one.